video we will discuss the remaining part of the previous video, and we find the lowest order relativistic correction for the Hamiltonian is h dash r, which is the relativistic Hamiltonian, is equal to minus p to the power 4 divided by m c cube and c square. Okay. Now, according to the first order perturbations theory, this is the first order perturbations theory, is psi naught n and h dash and psi naught n. So this is the sample is the expectations value of the unperturbed state. So, okay. Now for the relativistic, the first order energy is can be written as R. This is R. Okay, this is the relativistic. So is equal to psi naught into the h dash or Hamiltonian for the relativistic and psi naught. Okay. Now we put the value of the relativistic Hamiltonian minus p4 divided by m cube and c square and then psi naught n. Okay, this is constant. Now we shift this constant minus 1 over 8 m cube c square and then psi naught and p power 4 and psi naught. Okay, and p power 4 is not the Hermitian operator, then 1 over 8 m cube c square and psi naught and p square and p square psi naught n. Now the p square is the Hermitian operator, then minus 1 over 8 m cube c square is due to the Hermitian operator. This is can be written as p square psi naught and p square psi naught. Okay, this is equal to this one. Now we know the Schrödinger equations. The Schrödinger equations is p square divided by 2m psi plus v psi is equal to p psi. Okay. Now we transfer this term to the right hand side and then 2m psi and take the psi as count e minus 3 and take the psi as count. Okay. Now p square psi is equal to 2m e into e minus 3 and psi. Okay. Now we put this value into the above this equation. Okay. Then we will get E1 or relativistic energy is equal to minus 1 over 8 and m cube r square c square, no, r square, it's a c square, and then the expectation of the 2m e minus 3 psi and then 2m and e minus 3 and psi. Okay. Now this is constant and this is constant. This is constant. The 2m they are outside this. Then they become 10. This is m square and 4. This is cancelled to this 8 and m cube and then 1 over 2 mc square, and then e minus 3 whole square. This 2 is multiplied, okay, and then the expectation term. Now 1 over 2 mc square minus and is equal to the expectation of e square minus 2mv and plus v square, okay. Now minus 1 over 2 mc square we separately multiply. We separately take the expectations. Now the expectations of e is constant, and then the e square and plus minus, this is minus 2e, and the expectations of v plus v square and expectation of v square, okay. Now then here we put the value of the v is equal to the Coulombic potential as 1 over 4 pi epsilon naught e square divided by r, okay. This is Coulombic potential and e square, and here e is a constant, okay. Now then the equation is converted as minus 1 over 2 mc square into e square minus 2e, and we put here this term is become positive, this is negative, and then e square divided by 4 pi epsilon naught. These are constant, and now we write 1 over r is the expectation of 1 over r plus we put here, and this is a star of the v square, and then this is positive, and e square divided by 4 pi epsilon naught whole square, and then the expectation of 1 over r square, okay. Now with here this is En, this is a Bohr energy, okay. The En is a Bohr energy, and which is equal to En minus is equal to minus and m divided by 2h cut square and e square divided by 4 pi epsilon naught whole square and 1 over m square. This is the Bohr energy, okay. And here now the expectations of the 1 over r is equal to the expectation of 1 over r is equal to 1 over n square a, and the expectation of 1 over r square is equal to 1 over L plus 1 over half, and then n cube a square. We put this value into this expression, okay, and this, then we will get, then the energy is E1R is can be written as minus 1 over 2 mc square into En square plus 2En, and now E square divided by 4 pi epsilon naught into 1 over n square a, the value of the expectation of 1 over r, plus e square divided by 4 pi epsilon naught whole square, and then the expectations of the 1 over r square is L plus 1 over half and n cube a square. Okay, this is the value. And here the a is a Bohr radius, okay, which is equal to 4 pi epsilon naught and h cut square divided by me square, okay, me square. Then we can write the En1 or the relativistic energy as minus 1 over 2 mc square, and then En square plus 2En and N2 yes 4 pi epsilon naught, and to the value of the a. Here we put the value of a, then this is equal to m e square divided by 4 pi epsilon naught h cut square and then n square, okay, and plus then the value of the 1 over e square divided by 4 pi epsilon naught whole square, and the value of this is 1 over L plus 1 over half, and then the value of a square, we take the square of this value, then me square divided by 4 pi epsilon naught h cut square whole square, and then 1 over n cube, okay. Then the E1 or the relativistic energy is equal to minus 1 over 2 mc square is n2 or En square plus 2 En. Now we write this equation in terms of Bohr energy, then we can change these terms into the energy value. The energy value is this one. This is the energy value, okay. Now we transfer these value into this energy value, then we can write this equations, and now we produce 2 and then m divided by 2h cut square, then e square divided by 4 pi epsilon naught whole square and 1 over n square. We can simplify this term, okay, and then plus 4, we can write this term in here as m square divided by 4 pi epsilon naught. Here we produce 4, then e square divided by 4 pi epsilon naught and power 4 and 1 over n 4, okay, and then we can write this one, okay. we substitute the value of the En, then we can write this equation is minus 1 over 2 mc square is equal to En square plus uh, this is 4 times, and the value of energy is minus, then this is become minus, and the 2 multiplied to this is 4 times En, and one energy video is come from this video, and this is E square. Okay, and then plus 4, and here the squaring of energy to 2 times, this is become positive. Okay, then this is equal to En, this is the square value of the energy, then this become positive. Okay, and N divided by L plus 1 more half, and here the 1 more half is remain, and the remain is N divided by N plus 1 more half. Okay, this is N cube. We produce N denominator in the denominator, and then this is the N4 and N12. Okay, and this is this term. Okay, then like this. Now we simplify this term, then minus 1 over mc square is E1 is equal to minus 1 over 2 mc square, and then we can write again this En square minus 4En square plus 4 En square, and then N and L plus 1 over half. Okay, and this is the one term is minus this, and then 1 over 2 minus mc square, and this is a minus, but we have this is plus the 4 E square N, and N and L plus 1 more half, then minus 4En square. Okay, now this is can also be written as, we take common from this is N1 over 2 mc square, and then we common the En square, and then En whole square, and then 4n divided by L plus 1 over half and minus 3, and this is the relativistic corrections. So it is smaller by the factor of Em divided by mc square is equal to 2 n2 10 raised to the power minus 5. And this calculation we use the non-degenerate perturbations theory. Okay, and this calculations, in spite the hydrogen atom is highly degenerate, but the perturbation is spherical symmetrical, so it's commutes with the L square and Lz. Okay,